In this recording, we're going to learn how to factor completely. In other words, there may be more than one step in the factoring process to get it to be completely broken down into its factors. So we're going to look at these three examples on this page. Okay, I'd like you to put an asterisk next to these words. We will always check for a GCF first. That is the key step in this process. Look for a greatest common factor first. So as I'm looking at this trinomial, I see a GCF. Okay, hopefully you do as well. So let's identify that GCF. Okay, well, let's use our GCF factoring technique. So get as far as you can. You can peek back in your notes if you need to, but don't peek ahead in the video. See if you can factor this by taking out the GCF of 2. Then play the recording when you're ready. Okay, so hopefully you took out that GCF of 2. Okay, so there's our factorization. 2 and then x squared minus 6x plus 9. We've taken out the GCF, but maybe there's still a way to break this down further into its complete factors. So what I want to now do is look at what's inside the parentheses here, this quadratic expression, to see if perhaps this could be factored further. Well, if it could be factored further, it is going to be one of those basic trinomials that we looked at in our last lesson. So let's see if you could factor that. Set that up with your box, your window, and get as far as you can with this factoring, peeking back in your notes if necessary, and play the recording when you're ready. Okay, so hopefully you put your x squared in place and your constant in place. We're looking for all the factors of 9. And then we're looking to find the pair that adds up to a negative 6. So I've got my x and x factor, and I need these factors of 9, the numbers that go here on these edges, to also add up to negative 6x. Of course, that's going to be the negative 3 and negative 3, right? So my factors are going to be x minus 3 times x minus 3. So I keep the 2 in front. Don't lose that 2. I kind of like the way I've got it organized here. I'm kind of systematic about the way I'm breaking this down. I've got the 2 and then the quadratic. And now I've still got the 2. That hasn't changed. But now I've changed this quadratic into x minus 3 times x minus 3. If you wanted to be super duper fancy and write it as x minus 3 squared, that would certainly be correct. All right, so each of these is going to have 2 factoring steps. I'd like to see you get as far as you can. I think you have all the components, all the skills necessary to do this. Take out your GCF in each case, and then whatever's in parentheses, just like we did before up here, whatever's in parentheses needs to be factored further. Now, in practice, they won't always all be able to be factored further, but I'm telling you, these 2 can be. So go ahead and make sure you do that. 2 steps. Play the recording when you're ready. All right, so GCF. 3. Well, 3 is the GCF because there's no amount of x's that go into any of them, and 3 is the largest factor that goes into all the terms. So okay, so up on top, I'm writing what I multiply by 3 to get 3x squared. What I'm multiplying by 3 to get negative 6x. What I'm multiplying by 3 to get negative 24. And I can just kind of check that by distributing it back. Okay, we're halfway there. However, we can go a little further because this expression probably can be factored further. So I will draw my box down here. Okay, so I want factors of -8. Make my list. Okay, so those are all my possibilities. And I'm looking for the pair that adds up to -2x. So it looks like this one right here. Okay, so those add up to -2x, and that's what I had. And now I can write my complete factorization. So it'll be right here in red. GCF in front, and then the two binomial factors after that. Last example. Again, get as far as you can, please. Play the recording when you're ready. Okay, so this one, our GCF, we've got a 3 that goes into both terms. And I also need to look at the variables. Remember, it's the smallest exponent of each variable. So this is x to the first. X goes into x cubed, so 3x is my GCF. Okay, if you haven't done so yet, put in what your factors are up in the numerator, up in the top of this window, please. All right, good. So hopefully you wrote something like x squared, okay, because 3x times x squared is going to make 3x cubed. And then, let's see, -25. So if I do 3 times -25, I'd get -75. And then x times 1 makes an x. Okay, so we've got there a GCF factored out. But I'm wondering if this can be factored further. What if this right here could be factored further? So let's do it. What I have here is a difference of 2 squares factoring pattern. Remember, I don't have any x's. So whatever these factors are of -25, they have to add up to 0x. So let's see what our possibilities are. Okay, it's going to have to be this pair right here that adds up to 0x, essentially. Those on my diagonal need to add up to 0x. So those are my factors. Now I can write my final form. 3x, and this quadratic expression that I've underlined here gets broken down into x plus 5 and x minus 5. Thanks for watching.